Hello everyone, welcome back to my channel. Today we are going to talk about subnetting. As I mentioned in my last video that subnetting is a very important topic. It's a basic understanding of how the networking industry works. It's basically how you assign the IP addresses to a given router and how you manage the networks. So let's see how subnetting works, right? So let me take an example of where I have a network, okay, where I have like say let's say um, I have a host A, host B, host C, A, B, C. Now all of them are connected to a switch, right? Switch A. Now this switch is nothing but a layer 2 device. Its basic job is to basically forward the packets coming from all these hosts and send them out on the right interface. That's all the layer 2 switch does. Now let's say I have a router over here which is routing to the outside internet. Okay, this is the internet. Okay, now as a network engineer, my job is to assign IP addresses to A, B, C and my router, which is let's say router D. Okay, now let's say I have been given a network IP of 21.10.1.0/24. When so as I've already mentioned to you guys before that this is my network IP 21.10.10/24. An IP address is 32 bits where uh, this has 8 bits, 8 bits, 8 bits, 8 bits, total 32 bits. Now what happens is when it is /24, that means the first 24 bits are the network address. Okay, these are the network address and this is what I can use as host IPs. Okay, this is the IP address I can use now. Now since this is a network 21.10.1, 21.10.1, 21.10.1, 21.10.1, so this will be my network IP. And now as a network engineer I can assign IP addresses to this from, so I have 0 is a network IP, so I have 1 to 255, and in general 255, the last IP address in the given network, is used as a broadcast IP. So broadcast IPs are used when you want to send a particular type of a packet to all devices in that particular network. Okay, so if I have say 250 devices in the network, then I want to send that particular packet to all the 250 devices. It will just flood it. So that is what the broadcast IP is used for. Okay, now what I'll do is over here as a network engineer, I have the job of assigning the IP. So I'll assign this as 2, this as 3, this as 4 and this as 5. Okay, now now you would say like why 255? So 2 power 8 is 256, so I have 256 IPs. 0 to 255 is what that has been assigned to me, which I can use to assign to my hosts. Okay, makes sense. So now now let's say uh, uh, how do I use it more efficiently? Correct. I have 256 IP addresses, which is public IP address, and I have only 4 to 5 hosts. Do I need 256 IP addresses in this case? No, I don't need 256 IP addresses. Having such a large pool of IP addresses and not using them is not an efficient use of IP addresses, as we all know that IP addresses get exhausted very quickly if we're gonna waste it like this, especially. So there came this concept of subnetting where they were like, you can just use 8 IP addresses, or you can use 16, or you can use 128 out of the 256 you have. You don't need to use all the IP addresses. You don't need to have that kind of a network which has so many redundant IP addresses which are not used. So what I can do is I can convert this 21.10.1.0/24 to a /25 network and divide these 256 IP addresses into subset of two parts, where ranging from 21, let's say, okay, let's say first one is So as a network engineer, if my company has two departments, a finance and engineering department, I'll use 21.10.1.0 to 21.10.1.127 for finance. Okay, and this network IP would be 21.10.1.0/25. So now what about the other 25 other 128 IPs? That would be in the range of 21.10.1.128 to 21.10.1.255. So these could be used for engineering. And what will be the network IP for this? 21.10.1.128/25. Okay, so this would be my network IP. So I have divided 21.10.1.0/24 to a /25 network, where I have made two networks, one for finance department and one for engineering department. So now I have used them efficiently, as I have decreased the total number of IPs in one network. What I can use this for is, I can set different firewall IP table rules for both these networks, where I can have more secure rules applied for anyone who's trying to access the finance department IPs, and probably less secure for someone who's trying to access the engineering department IPs. So this makes efficient use of IP addresses. It is secure. It reduces the number of packets I'll have to send in case if you want to send a broadcast packet. The last IP in the given network is used as the broadcast IP, and in certain cases for certain protocols we have to send a broadcast packet. So instead of sending it to 256 hosts earlier, now I'll be only sending to 128 hosts. So this is basically helping me manage the network better by subdividing the network into another into smaller subnets. Okay, so also in the internet, right? So let's say I have another host over here. Let's say I have a host D over here. Now D wants to send message to A, right? So how does this D send the message to A? It will send the packet out onto this router. This router will look up its routing table and it will see that to reach this particular IP address, it has to check its routing table and see if that information is available on this device, right? So in this routing table, if this information is available, then we'll have the network IP of it, not the entire host IP address. So it will have 21.10.1.0/25 or /24, whatever is the network which we're using over here. Let's say we're using /24 only, right? Instead of having 21.10.1.2, it will have 21.10.1.0/24 in its networking table. So basically, any of these hosts ABC can be reached by this one lookup. Okay, it does not have multiple entries to reach multiple hosts. Then in that case, what will happen is the routing table on router B will be very huge, right? And on the internet there are millions of devices, so it cannot have so many entries in its routing table, right? So that's why we use the network IP. So the lookup is quicker, the table is smaller, and it's more convenient, right? It makes the system also faster. The data structure which is used to fetch and everything, the time complexity reduces. So that's why we use the network IP. So these are the advantages of using the subnetting concept over here and assigning the IP addresses. We also have this IPv4 subnet calculator. If you can just Google about the subnet calculator, it helps you to determine what mask is to be used, and what all usable IP addresses it will give, what will be your the network IP, what will be your broadcast IP, and how many host IP addresses you'll be getting. So let's, for an example, let's say that I have a network of 21.0.0.0/8, which gives me around 16 million IP addresses. But I do not want to use all the 16 million in one network. Maybe I want to divide it into sub networks, and let's say I have an IP, a host IP address of 21.0.12 or 25, which I want to use for a particular. Let's say that I have a network of 21.0.0.0/8, which gives me around 16 million IP addresses. But I do not want to use all the 16 million in one network. Maybe I want to divide it into sub networks. And let's say I have an IP, a host IP address of 21.0.12 or 25, which I want to use for a particular system. I just want it to be a part of a network which has very few IP addresses. Let's say I just want 8 IP addresses, right? So in 8 usable IP addresses, one will be for the network and one will be for the broadcast. So I'll get 6 usable IPs, and that's okay for me. So in since I just need 8, I'm using /29 as my subnet, because /29 means the first 29 bits of an IP address will be set to 1 and the last 3 bits, the 30th, 31st and 32nd bit will be set to 0. So 2 power 3 is 8, so I can use 8 IP addresses in this case. So that's why I'm using a /29 subnet. Now let's do calculate. So this should basically help me get all the information I can see, right? So if you see IP address 21.0.12.25 is the IP address which I want as a host, and the network IP will be 12.24 and the broadcast will be 12.31. Have IPs from 12.24 to 12.31. So like this you can divide a bigger network IP with a with many number of hosts, which say /8 or /16, or you have even /24. That will help me reduce the number of IPs by using a bigger mask, and that's what subnetting does. So just try it out. You can take a subnet, a bigger subnet, and then divide it into smaller subnets and see how that works. Okay, let me know if you have any questions on how to use this, and then we can discuss it offline. I hope this video will help you understand like how a network engineer should assign IP addresses to the respective hosts and divide the network into sub networks, if possible, to efficiently manage it and use it. So do like, share and subscribe, guys. Do let me know in comment section if you have any questions, if you want me to, or if you need any other help, then reach out to me, please. Thank you.